Hello and welcome back. It's Monday evening and it's amazing how quickly the time goes, isn't it? Nearly a week since I put the last video out, and again it's been another busy week. Did a trial yesterday and got the bike to clean outside. Had a couple of wobbly sections, a few fives. It was quite slippery, quite a lot of slippery logs to go over, but as I was telling my mate I was riding with, it's all good practice. So I actually did have a good time, and by the time I got to the fourth lap, sort of mastered some of the sections I was struggling with, so well and truly happy with that. In the workshop, again, time's been limited, was away for a couple of days this week, but did spend a bit of time in there. So we've got most of the frame main loop tubes cut. Top tube is now tacked in place with fittings on, and won't be long before I tack on this back tube between the front of the seat and the crossbar which the footrest mounts to. So actually not been too bad progress wise. So this video has got some of the work in getting as far as we have here on, a little bit of footage from the trial, and that's about it. But hopefully in the next coming week, again a little bit shorter time, going away for a couple of days, but I hope to get most of this all welded together, and when it is we can proper a hollowed out engine in place just to see how that's looking, and start thinking about subframe and swing arm mounts and such things like that. So looking forward to that. Hello again. Right, I've now turned up the two bearing cups and I'm going to get ready to assemble those to the headstock tube and weld them on. Give them a clean in the ultrasonic and the tube, and possibly not necessary for steel, but no harm in making everything as favourable as possible. So the first thing though is I've actually made these a slight interference fit on the tube so that it will help transfer the heat one part to another when I weld, and hopefully help limit distortion. So first job, over to the press, and let's just push these two cups on the tube. Right, it's got the tube reasonably in line with the first cup. Shouldn't be too difficult because the tube's quite thin walled and it's got a bit of give in it. And yeah, that's sliding in really nicely and gone down absolutely solid. So that's one end. And there goes the other end, and comes to a good solid stop. Right, so that's the first part. The next was these spacers that we made to mimic the bearings and to try and support the cup when we do the welding. They're also a very light press fit, so need also to get those in that one. And the same the other end. There is a slight pilot larger bore in the top of the cup. Help guide things in, and that's gone down nice and solid. Right, first test for alignment will be, will our fixture, bit of ground silver steel, go through the pair? And yes, that does. That's all, that's good. So we'll get the welder set up. What I'm also going to do is I'm going to preheat this slightly, only 100 degrees or so. The material I've used for these bearing cups, EN8, is weldable, but in heavy sections, and we're talking 18 mil or something, thickness, can be susceptible to cracking on cooling down. And so it's, if you warm things up and also then let them cool down slowly, there shouldn't be any issues. I'm not really expecting any issues, but it's an easy precaution to take. So I've got my little furnace up at about 100 degrees C, and I'm just going to warm that for half an hour or so while I set the welder up. Right, here's my welding setup. So I've used this big old sash clamp to basically clamp everything together. So these spacers are pushing onto this top cup, and the others stop by this bar. So the whole lot's in compression. And what I'm going to do is I'm just going to weld a short amount, maybe half an inch, something like that, quickly, then spin it through 180 degrees and do the same on the other side. Everything I'm trying to do is to minimize distortion. So let's see how we get on with that. Welder on, gas on. Yep, I think got everything, so let's give that a go. Just go handheld for a moment. So I've done 4 90-degree quadrants, so I'll now complete that to go all the way round. It would look prettier if I sort of didn't do it in lots of little steps, but this is the best way to stop any distortion. There we go, that's not too bad. So let's leave that to cool off in the oven, and then we'll think about the next bit. That's interesting. One of these welds had a little bit of porosity in it, and it was the sort of last closure weld, and I realised that effectively I'd almost got a sealed container here with just the very, very fine clearance between this pin and the bores it sits in to let gas out, and it probably wasn't enough. So I decided just to grind it out and redo that little bit of weld. And I decided to do that without this pin in place, just to let it outgas. And it just shows you how easily welds can distort things, because essentially I couldn't get the pin back through. It was probably 5-10 thou out of alignment this end, and all I could do was just do another weld the other side, just go over that again, warm up that side, then I could push the pin back in and just let it all cool, and now it's all settled. But it's just a good example of how easily even a small bit of welding can pull things out of line. And yeah, lesson learned for me: one, think about letting things vent, but two, keep all my systems in place to make sure things stay as true as possible. Another little job that I am going to do is these spacers that I'd put in to support the bearing cups whilst welding in everything else. This bottom one I need to shorten down just so this pin, my reference pin, sits on the bottom of the bearing cup there. Just saves having to make another allowance when I'm doing all the measurements. So I'll whip that out and skim it down slightly. Hello again. So we're on a Wednesday morning, and last night I spent quite a bit of time playing about with the CAD and just basically from a model putting the major dimensions of the frame on paper, so I've got something I can bring up here and reference. So importantly, the pin that sits below the bottom cup on the steering head is the sort of major point of reference on the drawing, then dimensions struck from it. And also I've got the sort of ground plane that's the base of the fixture as another datum to take dimensions up to. What I've done is I've set the pin up on the fixture to be at this dimension here, 523.9, well 524, and what I've now got to do is basically get a line on the fixture that allows me to get this distance here from the pin to the tube that sits between the front of the seat and the swing arm. And what I'll actually do is I'll position a bit of my 50mm box to sit here on the front edge of the tube, so then when I can clamp tube to it, we'll get this dimension down here. So that'll be the first bit to do on the fixture now. Right, so what I've done is I've set up my laser to be on the centre of this pin here. Hopefully you can just about see the laser light, and I've set the laser at a height so I get a little bit of a reflection. Obviously you can see it here, but a bit of reflection just on there, so that I can check that my laser's sat square onto the fixture, so I'm not going to get a sort of parallax error. And I've just scribed a line on my fixture here. So then I can see if we can get you in shot here. Basically, so I've scribed a line at this point here, dropping down from our pin, and I can then come back and do a line that is just sat at the front of this bit of tube, which is when I'm going to then sit my bit of box section in. So I need a line at 580 millimeters, 580 millimeters. So we will just mark that there. So that's where the back edge of our 50mm post should sit. And that should be where we want the front of our bidder box. You can just highlight that. Move that clamp along. Get that out of the way. We'll have to get the height of this right in a bit to support the top tube. It's going to be in the region of 300mm, so let's just approximately get that right for the moment. And then we can go from there. Right, so just make sure this is sitting square. Just put a bit of plate across there and tap. Make sure it's right, and again just square across the scribe mark. Again, the tube's sitting pretty well close to that, so if I nip that up for the moment. Still don't know whether this is the correct height at the moment, but we can tap it up and down as required. So let's try and get that height roughly right. Drop that in there. And I've got it wrong. I should be this side of the line. So, because this is where our tube sits, so let's just tweak that. Do that. Move that forward. Lift it up for a moment. Check our approximate height. Much too high. Let's come down about 25mm. That up. Another 5mm down. Nip that up. Right, it's nicely on the scribed line, but we're certainly not straight at the moment. So we just tap that to get it true. Actually, we're quite nicely on the line. Let's give that a good tighten up. Now the top tube should be virtually resting on that edge. Oh, no, sorry. Top tube should be resting on this edge. And our tube coming up here. But I need to adjust that height still. Hello again. Right, it's actually a good hour later since I started trying to set up to make this tube in here, and as I was setting everything up, something was just not correct. When I set up to the dimensions I got off the CAD at this end, here, effectively I was getting a very small gap, half mil max, or half mil ish, that end, and the angle I was getting on this tube, just fire that up, was about a degree out. And again, a degree doesn't sound much, but over this sort of length it's several millimetres. So something wasn't quite right. I spent ages going over and checking all sorts of things and struggled to find it until I actually went back and looked at the CAD. What I found was essentially on the CAD I'd got this pin, our sort of datum point, in the wrong place. It was effectively about 6 millimetres higher, would put it sort of embedded into the bearing cap. But actually on the CAD I didn't actually model the bearing caps on the frame drawing. It was just a controlled space from the bottom of the tube, which, had I modelled the cap, then it would have been very obvious straight away that I'd got that wrong. So anyway, I'm now found the error. I'm just about to repeat setting up. This height needs to be adjusted. That length that we took to the edge of this pillar needs to be adjusted. So I'm just going to get all that tweaked, then hopefully things will sit correctly. Just set up as before, at a 24-degree angle now to do this cutout where this tube that goes between the front of the seat and the swing arm meets the top tube. So I will cut that now. Won't bother you with filming all that, you've seen that sort of thing now, but I'll get that done and we'll try it in place. Right, so we've cut out the end of that tube there. I've added a couple more of my little brackets that allow me to clamp and adjust. That's been positioned to be on the edge of the tube. That fits reasonably well to the top tube, which will be eventually shortened. To get this to length, running across the bottom of the frame is a little bit of this box, and the end of this tube wants to be shortened to so this little bit of box can slide underneath, and that's going to be about 200mm wide under there. So we just need to mark that and shorten that. So what I'll do is I'll just get a height gauge with a scriber on it. Set it to the height of the top of that tube. There. And just scribe a line. It's a bit light, but I can improve that. Unfortunately, I can't quite get that up the spindle of my lathe, but we can cut it by hand well enough. Handy having that cut out in that bit of plate. So you've got a nice scribe line now that I can cut that off to. No, yeah, you can just see that. So we'll trim that off to that. Just trim it off on the saw, and then we'll mill it. There we go. Right, we're now onto the front down tube. Just cutting that roughly to length. Getting that ready to shape the end where it joins the headstock. Had to get a bit more creative to cut out the end of this tube to make with the headstock. So don't often use the horizontal spindle of this mill, but there we go, at least I can do that. Here we are now, getting some reasonable progress. We've obviously got the headstock, showed you earlier, top tube from the front of the seat going down to the bottom of the frame. Swing arm will be, pivot will be in this area. This will be oil filled. The ends will be blanked off with some blind bushes for one of the footrest mounts going in either side. Got front down tube going up, mated to the headstock. Nothing is actually welded by the bearing caps and the headstock at the moment, and that's because we've got fittings to be attached to the top tube for the filler cap. There's another hole underneath, you can just about see the oil outlet. It's got to be have a boss welded on there. So it's much easier to weld on all these fittings to the individual tubes rather than start welding the frame together and then trying to work in with the other bits of the frame potentially interfering with access to the weld. So next job is to start making up these fittings. So the filler cap, bosses for oil pipes. Just on the other side of this box section around here there will be a boss feeding oil to the engine, and to the opposite side of that we'll have a drain plug. So I'll get making those fittings up. Then when they're welded in and everything's nicely sealed, we can look at actually starting to tack the frame together. Just received the metal to make the filler neck that's got to be welded to the frame, and the bosses for oilways. First thing I always do when I get some metal, which I don't know what you can see there, it's just vibro etch on the end exactly what it is. I'm buying lots of various bits and pieces of material, and if you lose the identification of it, then it potentially is fairly useless. So this is EN3B, nice weldable steel. Importantly, it's not free cutting, it's not got sulfur or lead in it, which can foul up the welding. So as I say, that we've got to drill and tap to 15/16 to make that filler that's welded to the frame. So we'll get on with that next. Just made a start on the tank filler, or the oil and frame filler. So that's the 15/16 tap just going in there. So just got to work away to get that in to about 20mm depth. Morning. Right, I've just made the filler to be welded to the frame, but what I've got to make now is a mandrel to screw it onto so that when I weld it, it doesn't all go out of shape. So this is tacked 1620 TPI. I haven't a 1620 TPI die, so I'm going to screw cut a thread on this bit of bronze on the lathe. So I've set the compound slide at half the angle, and I've set the lead screw to turn to give me 20 TPI. Right, I'll just check that is a pitch of 20. Yep, that is. And that's going on fine, absolutely fine. Quick shot of the finished thread. And that now goes on nice and snugly. Just using a good old file to sculpt this out to sit on top of the tube. I could machine it, but there's quite a risk of it spinning off this mandrel, which I certainly don't want to happen, and it will end up as a bit of a mess. So do this the good old-fashioned way. I think we're there. So let's have a look. Looking quite nice. Right, there we are. You can see the filler cap on its little mandrel, and I put a spigot on the front of the mandrel just here, and that will help keep it aligned when I do the welding. So that fits on quite nicely now. So we'll just do the small boss to go this side, which is going to be much less complicated with a standard pipe thread, and then we can weld both of these on. Right, the oil return has got to come in here and you'll be able to ultimately see it feeding back in through the little pipe coming up. On a lot of frames, literally the sort of quarter diameter pipe is welded or brazed directly to this tube and comes up here. But I'm actually going to mount a little boss there and have a fitting, just because ultimately there's going to be two big plates on the headstock in this area here, and access to a pipe coming in here is going to be very limited. If it was welded or brazed and it broke or fractured, it'd be an absolute nightmare to try and do anything with it. So if we put a little boss in, stick a pipe fitting in there, then it's going to be quite easily serviceable. So just going to make this boss now with a 1/4 BSP thread in it, and it'll sit there and we can weld it in place. Here we are, just set up ready to tack weld the filler onto the top tube. So let's get the welder on and get going with that. Right, got a couple of reasonable looking tacks on there, so we'll get welding. So there we go, filler cap or spout, welded on. First bit of proper welding. And there we go with the filler and the oil return union in its boss. Don't know if you can see down there, not really. But the you can see where the return pipe will just come up. Try and get some light. Try and hold my phone to give a light and shine down there. Yeah, you can just see the return, where the return pipe will come up. So still on the top tube, and I've machined a hole where it's going to meet the down tube to the swinging arm, so the oil can flow into that tube, and just made a little end cap and tap that in to blank off the end of the tube, which I'll weld in now. Just ready for welding. What I didn't say was also I've really cleaned out the inside of this tube well. There's no point in having it full of swarf and grease and everything else, and then trying to clean out the frame before it's filled with oil. So the better I can make things to start with, the easier that job will be when we get to it. And there we go, end cap welded on. Just zoom you in quickly so you can see the laser line coming through the middle of the tube. I've checked the distance from the top of the headstock to the top of this tube, so we're all nicely aligned there. And if I move you down a little bit, don't think you can see the laser line very well, but I've then checked that we're equally distant that side and that side on the fixture, and the laser line, if you can see it, is bang in the middle of these two clamps. So let's bring the leads over and do a bit of tacking. Right, got a pretty good tack there. Try and do the same this side, keep things even. Yep, that's okay. Yep. That should be self-supporting. Out for the moment. That off for the moment. And just try and get a couple more tacks, so that's nice and strong. Pretty good. So that's 4 reasonable tacks. Just move you in a bit closer so we can see 1, 2, 3, 4. So that'll do for the moment. Don't try and score me, I'm just doing a bit of filming. Don't try and score us, I'm done. Thank you. hope you enjoyed the video. Keep coming with your comments and everything else. Subscribe if you want to, won't cost you any money. Just means you get notifications when I put new stuff out. I'm trying to fairly regularly put videos out either Sunday night or Monday night, something like that, so I will endeavour to keep going with like that. So thanks very much and stay well out there. Cheers.